This is video clip 3 for micro part 1. We're carrying on with consumer choice and focusing on the concept of utility. Some of this will be a recap from Economics 101, but we'll also look at how utility relates to the indifference curves. I'm sure you remember that utility is the pleasure or satisfaction that consumers get from consuming. It's not a characteristic of the good itself, but of the consumer's reaction to the good. So while one consumer might be ecstatic about a chocolate bar, another consumer might think it's just okay. We can't literally measure utility like we could measure temperature or mass or calorie value, but we imagine that we can, as a way of helping us to model how people act on their preferences and make consumption choices. So we assume that each consumer acts as if she can measure utility and arranges consumption so as to maximize her total utility gained. In reality, utility and preferences are really ordinal rather than cardinal measures. What does that mean? Well, an ordinal measure means we know the consumer's relative ranking of bundles, so we know 1 is better than 2 is better than 3, but we don't know by how much one is better than the other, or by how much one is preferred in numerical terms. A cardinal measure, on the other hand, is one by which we can make absolute comparisons between ranks, so we can measure the numbers attached to each rank. Money is an example of a cardinal measure, so we could say not only that one amount is greater than another, but we can also say by how much it's greater than another. And we use utils as an imaginary cardinal measure of utility, a numerical measure of pleasure or satisfaction from consumption that we use to help us model consumer choice. The utility function sums up the relationship between utility values and every possible bundle of goods, usually in the form of an algebraic expression. So for our pizza and burrito example, continuing with the simple example of Lisa consuming those two goods, utility is a function of pizza consumption and burrito consumption. So we might be told, for example, that Lisa's utility function takes the form, utility is a function of pizza and burrito consumption, and it takes the specific form that utility is the square root of the product of burrito consumption times pizza consumption. If we know what Lisa's utility function looks like, and we know how much pizza and burritos she has, we could work out a numerical value for utility, and that would be quite useful in predicting her choices. So, continuing with our example, if Lisa had to choose between these two bundles, deal 1 with 9 burritos and 16 pizzas, or deal 2 with 13 burritos and 13 pizzas, if we didn't know what her utility function looked like, we wouldn't know for sure which of those two deals she would prefer. However, given the functional form that we have, if we know her utility is the square root of the product of B and Z, we can actually work out that for deal 1, her utility would be the square root of 9 times 16, which is 12 utils, and for deal 2, her utility would be the square root of 13 times 13, 13 utils. So Lisa would get more utility from deal 2, and that would be the deal that she chooses. Now let's think about how utility relates to our indifference curve analysis. Remember, an indifference curve joins up all those bundles of goods that the consumer considers equally desirable, or all the combinations of goods that take her to the same level of satisfaction. In other words, all the bundles that correspond to a particular level of utility. So if Lisa's utility function is U is a function of Z and B, then on her indifference curve, we would say utility is constant. So U with the bar over the top shows that we have a constant value for utility as a function of pizza and burrito consumption. Marginal utility, I'm sure you'll recall from Economics 101, is the extra utility that a consumer gets from consuming one more unit of a good, or it's the additional utility from the last unit consumed. It's also the slope of the utility function as we hold the quantity of the other good constant. So, for Lisa's example, the marginal utility of good Z, or pizza, would be the change in her total utility over the change in her pizza consumption. How much has additional pizza added to her total utility? What is the extra utility gained from the last unit of pizza consumed? Figure 4.6 graphs Lisa's total and marginal utility functions for pizza consumption. So in the top panel we have her total utility function for pizza. We're holding burrito consumption constant at 10, and we can see that as her pizza consumption increases, as she consumes more pizzas per semester, her total utility is rising, as shown by the positive slope of her total utility function. However, you can also see that her utility is rising at a decreasing rate. The slope is getting slightly flatter. And that shows that her marginal utility of pizza is decreasing, although it remains positive. The marginal utility is the slope of the utility function, holding the quantity of burritos constant. And we can see that on both graphs. So if we look at the top panel, let's look at the fifth pizza. So in moving from pizza 4 to pizza number 5, that additional pizza, you can see, has brought her an additional 20 utils, or 20 units of additional satisfaction or utility. We can see this on the bottom graph as well, that fifth pizza has brought marginal utility of 20. The marginal utility is the slope of the total utility function. And again, you can see reflected here, marginal utility is declining, although it's still positive, it's above 0, but it falls, it becomes flatter as her pizza consumption increases. So the declining shape of this curve also reflects the declining slope of her total utility function. We're going to go back to our indifference curve analysis now, and we're going to see that there's an important relationship between utility and the marginal rate of substitution. Remember, the marginal rate of substitution, or the MRS, is the slope of the indifference curve. We will see that the MRS is the negative of the ratio of the marginal utility of another pizza to the marginal utility of another burrito. So the MRS, or the slope of the indifference curve, change in burrito consumption over change in pizza consumption, equals the negative of the marginal utility of pizza over the marginal utility of burritos. Or more generally, the negative of the ratio of the marginal utility of the horizontal axis good over the marginal utility of the vertical axis good. Since utility is constant along a given indifference curve, as we shift down the indifference curve, for example, giving up burritos and consuming more pizza, the change in utility from the extra pizzas must exactly equal the change in utility from the fewer burritos. Those two amounts must totally offset each other. Why? Because utility is constant along the indifference curve. Moving down the indifference curve, the utility lost from having fewer burritos must be exactly compensated by the utility gained from having extra pizzas. Let's look at that on our diagram. Again, there we have the indifference curve for Lisa's burrito and pizza consumption. All of the bundles along that curve take her to the same level of satisfaction. So utility is constant all along the indifference curve. In moving from bundle A to bundle B, Lisa is giving up 3 burritos and getting 1 more pizza. But her total utility from eating burritos and pizza stays the same from bundle A to bundle B. Why is that so? Because the indifference curve shows us all the bundles that bring her equal utility. So utility has to be constant all along the indifference curve. What that means is that the utility she's lost by giving up 3 burritos must be exactly equal to the utility she's gained from having 1 more pizza to keep total utility constant. This shows that relationship algebraically, that here we have her change in burrito consumption times the marginal utility attached to those burritos, which in this case is negative because she's dropped her burrito consumption, must exactly equal the change in pizza consumption times the extra utility from the extra pizzas. Those two must offset each other to keep her total utility constant. We can rearrange that expression, and we will get that the change in burrito consumption over the change in pizza consumption is equal to the negative of the ratios of marginal utility of pizza over marginal utility of burritos. Looking at that a bit more closely, this is the slope of our indifference curve. It's our marginal rate of substitution. There is our change in burrito consumption over change in pizza consumption, the change in the vertical over the change in the horizontal. And that we've just shown is exactly equal to the ratio of the marginal utilities she gets from those two goods. This is an important relationship that we'll come back to again when we look at the consumer's equilibrium and her optimal choice. In the next video clip, we will look at the budget constraint.